Okay, so you want to dive into data science. You've got your notes. And that How to Become a Data Scientist article from World Insider looks like you mean business. That article's a beast, though, gotta say.
It is comprehensive, yeah.
Yeah.
Sometimes a little too much, right?
Yeah.
That's what we're here for, though, to help you pull out those key takeaways, the stuff that'll really make a difference.
Exactly. We want you to walk away not just knowing what data scientists do, but thinking, hey, that's something I could see myself doing? Or maybe not. But let's start with the article's big idea. Data science is everywhere.
It really is. It's one thing to talk about algorithms and models, but seeing data science being used in agriculture to boost crop yields, even tackle climate change, that really struck me.
For sure. I mean, that table, the one listing all the industries employing data scientists, got me thinking. I knew Spotify used it for playlists and all that, but optimizing agriculture, that's next level.
Right. It shows you how data is changing things, and not just in the obvious ways. Like, we're not just crunching numbers here, it's about using data to solve some of the world's biggest problems.
Which brings up a good point. What do data scientists do all day? The article goes into the skill set, sure, but beyond the buzzwords, what's the actual work like?
Well, I like the analogy the article used. A data scientist is part detective, part storyteller, part coding wizard. Catchy?
Oh,
Yeah.
okay, I'm intrigued. But let's break that down a bit. What's the detective work, day to day?
Think data wrangling. You're taking raw data, often messy, and you're cleaning it, making sense of it, transforming it into something usable. Like a detective with clues, you're trying to find the story hidden in the data.
And then they have to tell that story, right?
Yeah.
Make
Yeah.
it understandable for those of us who don't speak data.
Exactly. That's the storyteller part. You could have the most amazing insights, but if you can't communicate them through visuals, dashboards, whatever it takes, those insights just stay hidden.
Okay, detective, storyteller. And what about that coding wizard bit? That's where the machine learning magic happens.
You got it. That's where the deep understanding of programming languages like Python or R, the algorithms, all of that comes into play. They're building the tools that can actually dig through tons of data and find those aha moments.
Speaking of aha moments, the article mentions something called predictive maintenance. Sounds almost like data science fortune telling.
It is fascinating. Imagine being able to predict when a machine's going to fail before it actually does. That's predictive maintenance. Data scientists build models using sensor data, looking for patterns that say, hey, this thing's about to go. Companies can then do maintenance before anything breaks, which saves money and can even make things safer.
That's wild. Okay, so data detectives, data storytellers, data fortune tellers.
I like it. But the article also talks about data analysts and data engineers. Important to remember there are different players on the field, so to speak.
Right, different roles within the whole data world, each doing their own thing.
Yeah.
How does the article break it down?
There's this great comparison table. It really clarifies those distinct roles, how they're connected. You've got data analysts, they're like historians looking at past data to understand trends, answer questions. Data scientists, we've talked about them. They're doing the detective work and the predicting. Then you've got data engineers. They're the ones building the systems that can even handle all this data in the first place.
So it's more about finding the right fit for your interests than saying one role is better, right?
Yeah.
Which is a perfect transition, actually, because this article really gets into the skills needed.
I gotta say, looking at that list of skills in the article was a little intimidating. Math, coding, cloud computing. It makes you wonder if you need a PhD just to get started. Yeah, a lot of people think that, but the article actually does a good job of showing it's not the only way. There are multiple paths into data science, some more formal, some self-taught.
That's good to hear. So you don't necessarily need to go back to school, rack up a ton of debt.
Not at all. The article has this table. It compares the pros and cons of, like, a formal degree versus just learning on your own. A degree gives you structure, sure, and those credentials can be helpful. Plus, you get internships, networking, all that.
But self-learning, that's got its advantages too, right?
Absolutely. It's flexible. You can learn at your own pace, focus on what matters most for your goals. And there are so many resources online now, boot camps, communities.
You're not just out there on your own trying to figure it all out.
Exactly. And the article really stresses this point. Practical experience often matters more than having a bunch of certifications. There is a quote from this leading data scientist, Dr. Emily Chen. She says, I'd rather hire someone who's built a working model in their spare time than someone who's just memorized algorithms from a textbook.
Which makes sense. It's like you can read cookbooks all day, but until you get in the kitchen and actually make something.
Exactly. And with data science, that making something often means getting your hands dirty with real data, building projects, seeing what works.
Speaking of getting our hands dirty, let's talk about the math. Now, math and we have a bit of a history. Calculus, linear algebra, all those things the article mentions.
Yeah.
Sounds intense.
It can seem that way, yeah, but the article does a nice job of breaking the math down. It's not about memorizing formulas. It's about understanding the core concepts and how they actually apply to analyzing data. Like, remember calculus? A lot of us thought we'd never use it after high school.
Definitely thought that.
Turns out it's the basis for a lot of machine learning algorithms.
So it's less about doing complex equations on a whiteboard, more about how those equations translate into real-world stuff. Can you give me an example? How does calculus play into, say, those Spotify playlists we were talking about?
Good question. Calculus is what helps power those recommendation algorithms, the ones deciding which song or artist to play next. It's used to analyze your listening history, compare it to millions of other users, and then find those patterns, predict what you might like.
Wow. Okay, that's actually pretty cool. So it all comes together. But the article doesn't stop at the hard skills, does it? It talks about soft skills, which I don't think people always consider.
You're right. There's a whole section on soft skills for data superstars because those are crucial too, often overlooked. Technical skills will only get you so far. To really succeed, you need to communicate your findings, work well in a team, think about the ethics of what you're doing,
So it's not enough to be a data whiz, you got to be a data whisperer too.
and a team player on top of that.
Exactly. Data science is rarely a solo thing. You're working with people from all different departments, explaining complex stuff to people who might not be technical at all, and then you're collaborating with other data folks to actually build and use those models. Communication, collaboration, being able to adapt, those skills are huge. Okay, so we've got the skills down, the different paths you can take, but what's it actually like day to day being a data scientist?
That's what we're going to talk about next, and the article gives a pretty good glimpse into that world.
I'm guessing it's not all sunshine and aha
Uh,
moments,
well,
right?
it's not always a straight line to those aha moments, that's for sure. But that's all part of it, and we'll dive into that right after this.
So we left off talking about what it's really like to be a data scientist day to day. But before we get to that, the article talks a lot about building a portfolio. And not just any portfolio, right? It has to be good.
It really does. I mean, anyone can say they can wrangle data or build a model, but a portfolio, that's where you actually show what you can do.
Makes sense. So no more hypotheticals. It's about getting down to business, even in the portfolio.
Exactly. Like, remember predictive maintenance. The article suggests building a project around that. Find some sensor data that's publicly available, build a model that predicts equipment failure.
That's a lot more concrete than what usually comes to mind with portfolios.
Right. Or like analyze social media sentiment, maybe for a brand you like. Or how about building a whole recommendation system for a streaming service? There's tons of data out there you can use.
So you're not just learning the tools, you're actually using them to solve problems,
Yeah.
which probably takes some serious initiative, right? Something else employers are looking for.
For sure. The article talks about being a self-starter, someone who can take on messy problems, figure things out, and be ready to learn new stuff constantly because this field changes fast.
Way fast. I feel like there's a new tool or technique every other week. But the article doesn't just leave you hanging, does it? It actually talks about how to keep learning, even after you land that dream job.
Yeah, continuous learning is key. It's like the article's mantra. Go to conferences, join online forums, contribute to open source projects, get involved.
It's like they said, the best data scientists are lifelong learners.
I love that.
Yeah.
Okay, so to wrap things up, we've gone from, like, what even is data science to how do I build an awesome portfolio? And even got a glimpse into the daily grind.
And we just scratched the surface. There's so
Well-
much more to explore. Exactly. Data science is bursting with possibilities. And the cool thing is, it's not just for the experts. It's a field that's constantly evolving. And anyone with the curiosity and drive can be a part of it. So to all our listeners out there, keep asking questions, keep diving deep, and who knows, maybe you'll be the one using data to change the world. Until next time.